In this video, we're going to be looking at circular motion, what it is. But before we start with anything, let's just quickly take a look at how to convert between degrees and radians. So radians and degrees are both angular measurement techniques. Radian is equal to pi over 180 times by how many degrees you have. And to get it into degrees, that's equal to 180 divided by pi times by radians. So what is a radian and what is degrees? So if you have a look at 360, if you have a look at a circle, inside the circle, if you go all the way around, you have 360 degrees, and that is equal to 2 pi radians, which is also, if you do 2 times by 3.14, which is the value of pi, it's basically 6.28 radians. So 180 degrees is equal to pi radians, and that is equal to 3.14 rad. So it's basically, you can convert between the two fairly comfortably and easily, just like that. So what we're going to do is we'll start off with circular motion. So circular motion is when an object travels in a circle like this. So the midpoint is the reference point. So if an object is on a string and is on a string like this, and the string goes around the circle like that, this object, if it's going around in a circle and you cut the string at this point over here, it's going to fly off in this direction with a speed of v. So that's going to be the velocity of it. And also with circular motion, we can actually measure how quick something is moving by looking at how many degrees it's actually turned out per second. So for this one, and what we're going to say is this object is going to be turning out this many degrees per second, and we measure that in terms of omega, and omega is our angular velocity, measured in radians per second. So that's the unit that we have for angular velocity. Velocity is always in meters per second, and it's just fairly straightforward. That one is, we've met it before. So this object over here, there's actually an important force acting on it, and the force that is acting on it is actually the centripetal force. Centripetal force, by the way, is a combination of different forces acting on any object that there is. So for this one, centripetal force is always acting towards a midpoint of any circular motion. So for this one, centripetal force is acting in this direction, and we can also put on there the centripetal acceleration. So AC is our centripetal acceleration, and FC is our centripetal force. So this here is measured in newtons, and this here is measured in meters per second squared. So there is two quantities that we've got to think about. Another thing that this angular velocity, people get very confused with it. So I'm just going to highlight over here that if you have two objects moving in a circle, and object one, there's an object over here, and a second later it ends up over here. But for object 2, it only ends up over here a second later. So this one. So which one has a greater angular velocity? Well, this one here. So object A, this one here has a larger omega value. So there we go. So how do we actually determine? What are the formulas for all of these? So angular velocity is given by 2 pi over t, and as we know 1 over t is f, we can say it's also equal to 2 pi f. V is equal to the circumference divided by the time period of a circle. So this one is 2 pi r over t.